Alright, cool. Alright, computer now is finished booting. So we are up.
Man, I was in the 4th grade on this iconic day.
I had a physiological ecology class. We met at 9. Or 9:45 was the class. So I didn't know what happened until I was there. Another grad student came in.
I have no clue what was going on. I just knew that they stopped class and all the teachers were watching the TV and we were just sitting on the road.
And not much got done. Had a actual faculty member, their son, daughter, their child worked in New York.
Really? Oh, that's scary.
I think they were, I don't think they were in the towers, but that's their company was in the towers. Lower. Yeah. All right. So we did. All right, so we did, let's see here, weighted averages, did our means. All right. All right, so let's get going here. We've got measures of central tendency. First up was mean, right? Arithmetic mean kind of gives us the balance point, right? Second measure of central tendency is the median. The median is the 50% point. That's what it is. It's basically defined that as the 50%. All right. How do we find it? It's actually pretty easy to find once I show you how. So in R, there's a median function that will do that for you. It'll return the median. And however we calculate the median, we normally get the exact same thing. And you could say normally, shouldn't we always get the same thing? Like, not really, because there's a question of what do we do when we have ties? When we have ties in our data set, how do we handle ties? And there's actually several different ways to do the median. So, all right, so our median is this location statistic. It's going to be our point where we have 50% of the values to the left, 50% to the right, all right? And then we have our convention on how we do it when we have an even versus an odd number, because if we have an odd number of data points, then we have an exact middle point. If we have an even number of data points, then we've got 2 points that are actually in the middle. And in order to report the median, what we do is take the average of those 2 middle numbers. Now, how we're going to do it, duplicates don't have any effect. Right? They're not going to change how we calculate our median, but it could affect how R would calculate the median. So let's open up our R markdown and generate just a simple randomized data set. Alright, so move this over. So I got my R Studio open. This is the descriptive stats worksheet. I'm going to go ahead and run my chunk because I know we're going to use it. So I've got my av1, av2, av3 all set up. Then I'm gonna go down here and start a new one. And that's on medians, all right? All right, so we're gonna generate a sample data set. All right, we're gonna do 2 of them. All right? We're gonna do odd. All right, this is just an odd number of data set. All right, so what we're gonna do is use 7, hopefully 7 numbers. All right, so my data set's going to be 4, 5, 5, 6, 8, 9, 9. And I did that so that they're in order. Right? So I'm making them in order. And then what I'm going to do is make a new data set and just call it even. All right? Even data set. And what I'm going to do is going to have the same numbers. So 4, 5, 5, 6, 8, 9, 9. And then I'm going to add a 10 to that data set. So we have one more data point, one more sample in our data set. All right, so, and I'm going to run this. So I have even and odd. So how do we do the median? Well, median is our 50% point. So what we're going to do is simply look at our values. So if we were doing this by hand, I take our values and I arrange them from smallest to largest, like I have here, and then I find the middle value. And for our odd number of data points, we have a middle value right in the middle. So that 6 is our median. All right? That 6 is our median. Can we confirm that? Yeah. So we can use the median function. So the function itself is median x, where x is a vector. And I'm actually going to be a little bit more clear and say x is a numeric vector. And just to add a little bit more, is we may need to use na.rm equals t if we have any missing data points. All right, so we're going to confirm that our median is actually 6 by typing in median, and then odd. So we're doing the median of that vector, and when I run it, I get 6. All right. Not too bad. What if we have an even number of data points? The even number of data points, we still want the 50 percentage point. We want that point where 50% are below a number, 50% are above a number. So in our even data set, I have 4 data points there. I have 4 data points here. And that means our median is going to be someplace between these 2 numbers. And our rule of thumb then is to take the average of these 2 numbers, which should give us a median of what? 7. All right? So let's check that. Gonna go to the same chunk. And I'm gonna run, or I'm gonna add in median of the even vector. And you will see that I get a median of 7. Now, what's this business of duplicates, and we may get something else? So I'm going to go over here into our search bar, and I'm going to type median. All right? And I'm going to do a search to get to the help file. And here's our help file. Median value. Over. Slide it over. We're not blocking any of our screen. All right, so what you're going to see is it gives computes the sample median. I got median of x. All right, and it's going to return everything that we needed. And it's going to return, it can take the median of the dates. So date is a time. It can do all of that. But it becomes important when we get down to here to this quantile function. So the quantile function utilizes median. We're going to talk about these quantiles because once we get to here, in our function itself, it has this type equals 7. And if we were to look up any stats books, you're going to see that different stats books have a slightly different way to calculate these quantiles and medians. The median that I gave you is, it's the standard. You're going to see that basically in every single book. But there are some that will take into account duplicates a little bit differently than how we would take it. So the type here in the help file says it's an integer between 1 and 9, selecting one of the 9 quantile algorithms detailed below. So here, when we see the quantile algorithms, we have types 1 through 3, our discontinuous sample quantile, types 1 through 3. 4 through 9 is for continuous sample quantiles, and the default is 7. So these are all just kind of different equations on how to get the quantiles based on the number of samples, duplicate values, and so forth. Are we going to worry about this? No, not really. I present it here just so you are aware that if you do things by hand, if we calculate the median by hand and then use a computer program to do it, there is that possibility that you'll get a slightly different number. And the reason it gets a slightly different number is based on all of these algorithms that they could use. All right? Medians, likely going to be the same across all textbooks. Quantiles might be a little bit different. All right? That's not too bad, right? I do have a review. Just remember length of our vector, and then in brackets, exclamation point is .na, and then our vector again calculates our actual sample size. The length gives us how many rows we have. This function gives us the actual sample size, so it only counts non-missing data. All right, so medians gives us the 50 percentage point. Quantiles and quartiles gives us different percentage points. All right, so the quartiles will return our 25th percentile and our 25th percentile and our 75th percentile. All right. We can also get our second quartile, which is our 50 percentage point. All right. Or we could do like a 10th percentile or a first percentile, 5th percentile, all of these things. These are all related, and they're referring to the number of points that we have in our data set, certain percentage of points. All right, so the quartile is derived from our basic standard distribution. We're splitting things up into quarters. So we've got the 25th percentile, which represents our first quartile. We've got our second quartile, which is between 25 and 50. Our third, which is 50 to 75. And then our fourth, which is the 75 to 100. So in theory then, our fourth quartile should be the largest value that we have in our data set. All right. And then the quantile is the percentage point in our distribution. Why do we do these? The quartiles are used to calculate this interquartile range, or IQR. IQR is a non-parametric equivalent of our standard deviations, or it's a measure of spread of our data. All right. If we're going to analyze data, if we're going to analyze medians, because maybe we are not normally distributed, we shouldn't be using standard deviations or standard error or confidence intervals. We should be using these interquartile ranges. All right. So, and then the quantiles percentage point, and we'll do those. We'll look at 2.5 percentiles. We'll look at 97.5 percentiles. Why? 2.5 and 97.5 percentiles will give us 5% in our tails. Right? Why is 5% important? What's our cutoff for p-values? Anybody? 0.05, which is 5%. So we're going to use those. All right, we're we're going to use these. All right, so there is a quantile function in R. It's called quantile, where we give it our vector, and then we give it the vector of probabilities. And again, just like our medians, we may need to use na.rm equals t. So I'm going to go back to our R Markdown document. And we created these so we can do them ourselves. So I'm going to use the board and show you how I do it by hand. Again, so the medians, we should get the same answer. The quantiles or quartiles might be a little bit differently. So I'm going to use this small board up here. Here, I zoom just a little bit more. All right, so we have our data points. I'm going to line them up from smallest to largest. 4, 5, 5, 6, 8, 9, 9. All right, they're lined up right in a row. We want our median. That represents our 50 percentile point. So we have 50% below, 50% above. All right. Now you should recognize that it's kind of, what do we do with that last point then? Because we've got more, 50% here, 50% here, that equals 100, but we've got 6 in there, right? That's kind of where our issue lies. That's why there's so many different ways to calculate quantiles. All right, so we go to the middle value, that's our median. Make sure I'm not writing too long. And I was. This up. Oh. There it is. Sorry, those of you watching. All right, so our median's that middle point. And then we've got this batch, and we've got this batch. So our quartiles are going to fall someplace in here. And what I would do is I look at these points then, so we already have our median, and then of these points, I find the median of those. So this would represent our 25th percentile, or our first quartile. This point represents our 75th percentile, 75%, 75th percentile, or our third quartile. Where's our second quartile? That's our median. Quartile. Right. So all I did is we found our median, and then I looked at the remaining points. The median of that is going to be our first quartile. Go to our upper. The median of that upper is going to represent our third quartile. All right? Questions on that? How well do we do? Well, let's check it out. All right. So I am going to go to R. All right. We already have our quartile function. All right. And we're going to calculate quartiles using quartile vector x probs equals c dot dot dot, where x is our numeric vector and probs is a vector of percentiles in decimals. Make sure you mark that. All right, so we're going to start with this odd vector. All right. Now there is a default. The default is in the help file, and it says the default is prob equals c 0, 1, 0.25. All right, that's what this says. Sorry. highlight that. What this function does is it generates a sequence between 0 and 1, skipping every 0.25. So the default will give us 0, 0.25, 0.5, 0.75, and 1, which is exactly what we want. Right? We almost always want those, with some exceptions. So we could do the default quantile of odd, and when I run that, it gives me my 0, 25th, 50th, 75, and 100th percentile. And then we have to recognize that 25 and 75 represent the first and third quartile. Do they match? Do they match how we do it? One does. The other one does not. That's where I'm talking about the different types. The default was this type 7. We're just going to leave that R as the default. We're going to recognize that we did it a little bit different. Are they wrong? No. Neither answer is wrong. All right, so what's that?
Is it quantile or?
It is. It's quantile.
So should it?
It is quantile.
Is there a quartile function?
I don't think so.
So they changed
There is in a package.
Okay.
You can find it. Did yours work?
No, I put quantile up in the.
Yeah, he said
Yeah.
Quantiles.
Yeah.
Yeah, he changed.
Should be a quantile
Okay.
up here. Sorry. Should be quantile up here. Using quantile and quantile x probs. All right. So what I'm going to do is add this probs because we want to check our first and third quantiles. We already know the median. The median was 6. We calculated it as 6. So how do we specify we only want the 25th and the 75th percentile? We give it a vector. We actually specify which percentiles we want by specifying probs. So probs equals C 0.25 comma 0.75. So what we did is we said probs is a vector, and the vector that we want is 0.25 and 0.75. When we run that, now we will only get our 25th and 75th percentile out there, or our first and third quartiles. So calculated quantiles may differ when comparing R's values and values calculated by hand. And this is due to the type equals 7 option of the quantile function. All right, nothing to worry about. Nothing to be overly concerned about. Just kind of clarifying that how we do it by hand may be a little bit different than how R calculates it. So if you're doing something by hand and you say, I'm just going to check to make sure that I'm doing it correctly, and you use R and you get a different value, don't panic. We've got it here. It could differ. What about even numbers? All right, so even numbers, let's get this on the board. Doesn't really change much. Again, our rule when we have an even number is when our percentile or when our median fell between two numbers, then we took the average of those two numbers. The same thing's going to hold true for our quartiles. All right, so we've got our value 4, 5, 5, 6, 8, 9, 9, and 10. All right? So that was our sequence of numbers. I arranged them from smallest to largest. All right, we go to the middle point, and our middle point is right there. All right, that's our median. That's our 50th percentile. That is our second quartile. That's our second quartile. I should say, as I step back, you could wonder why this comes into place. It was with that 6. We said 50% was below, 50% was above. What do you do with that 6? That's exactly what these different types are kind of accounting for. Right? Do you include that median in the lower? Do you include it in the upper? Do you include it in both? So those are the issues. But we're going to do it a simple way. So 50% is the middle point, right? It is going to be the average of these two numbers, which is 7.5. I'm sorry, 7. 5, 7, 6, and 8. So that's our median. All right, and then we need to know our first and third quartiles. So that's half of the points below that number. That's half of the points below the number. So if we only look at those points, the median is between 5 and 5, which is 5. So that's going to be our first quartile, or our 25th percentile. The upper one, 8, 9, 9, 10, we're going to look for the median of that, which is between 9 and 9, which means 9 is our third quartile, or our 75th percentile, or 75th quantile. All right. So what we're going to do is, if you do this by hand, it's just look at the median of the lower half, look at the median of the upper half. Let's check. I'm going to also do this here. So quantile of even, right? The default is going to give us the correct percentiles. Or we can specify. So here I'm just going to say, let's look at 0.025, 0.25, 0.5, 0.75, and 0.975. Why those numbers? Arbitrary, somewhat. When we calculate a confidence interval, we're interested in having 95% of our values, 95% of the middle values, which means we have 5% in the tails. What are those 5% in the tails? Well, it's the lower 2.5%, and it's the upper 2.5%. And the quantiles always refer to the beginning and incrementing higher. So if we wanted 2% down here, we're at the 2.5%, or if we want 2.5% down here, we're at the 2.5% quantile. If we wanted the 2.5% at the very top, we're actually at the 97.5 percentile. All right, so we're going to use these. I'm just going to introduce that here. Now I'm going to run it, the chunk, and you can see that we get the values that we got as we calculated. We got 5, 7, and 9. Just exactly how we calculated it. But we would have the same problems. If we end up getting even or odd numbers, odd number of samples in our different groups, we could get slightly different answers than how R would calculate it. Easy? All right, move this over. All right, so here's our probs, just to kind of clarify it so you have it in your notes. All right, and I'm giving you the most likely ones that we can encounter, ones that we'll probably encounter this semester. Probably will. We will encounter these this semester. Let's make that. Sorry, guys. The YouTube screen, I forgot to enlarge the YouTube screen, so they were squinting. I'm damaging their eyesight. Don't sue me, sue the school. All right, so these are the most common probs that you would use. So you would do probs equal this default. And a lot of times, if you're going to use the default, you don't even have to specify it. You don't even have to specify probs. Just do quantile and then your vector. All right. If we only wanted the first, second, and third, we could specify it as C equals 0.25, 0.5, 0.75. All right. You can do that. This avoids having to use the median function to get to 50%. The quantile function will give it to you. If you wanted upper and lower cutoffs. So one thing we will use is we will generate random data, a random sample, and generate confidence intervals from that random sample. It's called bootstrapped confidence intervals. And the bootstrapped confidence intervals utilizes this. So it's going to get the upper and lower cutoff for 95%. There's our 2.5 percentile. That's our 97.5 percentile. We'll work with that. Maybe we're trying to figure out a cutoff for comparing a p-value. We want to know, or we generated our own random test statistic, and we're comparing it to a null distribution, in which case we need to know what our 5% cutoff point is. So the lower tail cutoff point is 5%, or probs equals C 0.05. If we wanted the upper tail, it's 0.95, so 5% in that upper tail. So these are going to be the most common probs that we use, and you'll see them reappear. Any questions? All right, so here's quantile. We already did odd and even. All right, and we could do quantiles of our AB1, AB2, AB3. But I thought I'd make a little bit more realistic examples. So, number one is this 50, 70, 90, 50, 30, 100, 70, 50, 40, 90. All right, we're kind of on a pretty wide range. Probably doesn't make sense to calculate averages and utilize averages for comparison purposes because we have at least one order of magnitude difference. We have 30 all the way up to 100. And it's a pretty big difference. So maybe we're going to compare the medians instead. So if we're going to compare medians, our measure of dispersion will be these quartiles, this interquartile ranges. So what I want you to do is practice is make these vectors, call them DAT1 and DAT2. All right. And then for DAT1, we're going to calculate the median, the quartiles, and the 95th percentile. For DAT2, calculate the median, 2.5, and 97.5 percentile. Right? I will get good practice. get it? Work. Slide over. Go. All right. So I made my dat1, dat2 vector. Hopefully it is, when I said how to do that, you immediately remembered how to do it and you can make it, no problem. That's at least worth, I don't know, 3 points on the exam coming up. Just doing a vector, pretty easy. Right. So I made dat1, dat2. I ran the chunk so I know it's there, it's in my environment. All right, and then for dat1, we need the median, quartiles, 95th percentile of this vector. So I'm going to do quantile dat1, and then we have to specify our probs. So which ones did you use? All right, so that's what I heard. 0.25, 0.5, 0.75, 0.95. Did it work? Yep. There's our answers. 50, 60, 85, 95.5. So note the difference. We're asymmetric, so if our interquartile ranges can be along with the median, can reveal skew in our data. All right. Non-skew means we're symmetric. So we have equidistant between the median and our quartiles. But you can see we have 10 units from the first to second quartile, but we have 25 units between our second and third quartiles. So we can kind of use some of this to judge or help us judge normality. In this case, symmetry. All right. So we did that for dat1. What about dat2? Yep. So I'll just do 0.5, 0 point. So we want our median, and then 0.025 and 0.975. All right. Is this going to work? I didn't put them in order. Should it work? Oh yeah. It's just a vector. It's going to go one by one. It's going to say, okay, give me the 50 percentile, which is the median of dat2. Then give me the 2.5 percentile. And then give me the 97.5 percentile. So you don't have to do it in order. Usually makes it easier. But for this problem, I just said give the median, 2.5, and 97 percentile. 97.5. So that's how we do it. So what this tells me then is that 95% of our data points fall between these two numbers. So 95% of our data points fall between 1.3 and 9.4. That's kind of important because our cutoff is 5%. If we fall outside of these numbers, it's possible that that number didn't come from our distribution. And we'll get to that. We'll talk about doing it. Any questions? Most likely mistake that happens is that you use quantiles with an S at the end. How do I know that? Is that I do it all the time. Do it all the time. And it doesn't work, and it's like, dumb me. You should learn about it at some point. But no, I always make a mistake. All right, so medians and quantiles. So median represents our location. The interquartile range, or quartiles, represents our distribution. So when do we start to use these? We use them when we have non-normal data, or we can use them when we have non-normal data. What does it mean when we're non-normal? Well, we could be skewed. We could be asymmetric. All right, so it doesn't make sense to have symmetric error bars if our distribution is very skewed. If we have a lot of big numbers, or we have a couple of really big numbers that are going to throw off all of our prices, or all of our calculations. So examples of these are home prices. All right, you will see median home prices being reported. All right, the reason for that is that we have a couple of houses that will sell for a whole lot of money, and that'll bring up the average. So like around here in St. Angelo, they may say the average sale price of a home could be, let's say, $250,000. And if someone looks at that, they're going to say, wow, that's, it's kind of an expensive housing market. But if we report the median, and the median is 150,000, what does that tell us? What's that?
There's some houses that are expensive.
Yeah, it tells us that there are some houses that are expensive, some that are not, and 50% of our houses are in that 150% or that 150,000 range. It's more representative of what's actually happening. Salaries are reported in the same way. I mean, if you look at, and you're here as we enter, we're already in the election season. All right, you're going to hear, I'm sure, a lot about average salaries. Average salaries of the workers. All right, is that reflective of our workers? Not when you have the 1% making, several $1 trillion a year or gazillion dollars a year. That's going to bring the average up. Median salaries is a better indicator of the 50 percentage points, what 50% of the people actually make. All right, so salaries, home prices. The other time we can use medians and quartiles is when we have limited times or resources. And this is a special case. So what we're interested in maybe is environmental contaminants and their effect on organisms. So there's this thing called the LD50. It's the lethal dose that kills 50% of our organisms. All right. In order to calculate it, we don't actually do every single dose. I mean, in order to do dosage itself is on a continuous scale. You can't possibly do every single possible dose to get that exact dose where 50% of our individuals die. So what we do is do dosages at like maybe 2 log increase, so doubling of our dosage, or maybe 10 times the increase of our dosage. And what we see is we have a certain number of individuals at a point that die, and then at the next dosage we have a couple more die. And what we do is extrapolate, interpolate between those data points to figure out where that actual 50% dose is that kills, or that dosage is that kills 50% of our individuals. So in those cases, then we do report the medians and interquartile ranges. Questions? All right, so we'll end with mode because we hardly ever use it. It is just the most common value. That's all it is. You've probably learned it in grade school. My daughter learned it in grade school in 4th grade, reviewed it on the online platform. It's going to be our peak of our histogram. All right. Only time we see it in biology is if you're looking at, let's see, most common colors, most common phenotypes. That's about the only time you report it. So what we'll do is we'll pick up, because here on Monday, what we're going to do is kind of just do a quick review of our central tendency, and then we will move to dispersion. All right. And I think on Monday I'll post the homework assignment. That includes our central tendency and includes the measure of dispersion. So if you wanted to stay later after our lab on Monday to start working on it, you can. Would you be able to do all of it? Technically, no, but if you look it up in R, you could probably complete all of it. All right? All right, have a good weekend. I'd say try to stay warm, but it seems like we might break the 70s. I may have to go back to wearing shorts.